Hi, this is George from the product team at Fiveonefour, and I want to show you guys our new Aurora AI agent that uses planning to build good Moose data projects. So first things first, I'll run a Moose dev server locally. If you don't remember, Moose is our open source developer framework that uses software engineering best practices to help you build data engineering infrastructure and projects quickly. We have just run our local dev server here that builds all of the parts of the data infrastructure that you might need in scale locally. So that's like Rust ingestion servers. It is Red Panda for streaming, ClickHouse for storage, whatever else you might need. This is so that as we build our project, we can test it against that infrastructure, and we can then deploy to production using our commercial hosting platform, Boreal. So I don't want to build all those primitives myself, so let's try to ask AI. So let's run Aurora agents. So now you'll see something new. We got a supervisor agent. It's going to ask us what we want. So let's build a functional data warehouse. I want to get data from this source periodically to build a time series, which is a simple data engineering project you might have. You'll see now the supervisor is taking a second to think. It's asking itself what the minimum set of questions that it needs to ask me is to be able to do its job. So what is the desired ingestion frequency? Let's say every 5 seconds. Does it require any authentication? No, but it does require a user agent header. What specific fields? All of them. How do you plan to interact? Giving the data to AI. Are there any additional sources that you would like to integrate? Not now, but yes, in the future. Would you like to refine the spec? No. So now the supervisor agent is going to build a specification in the temporary Aurora directory here, and that's going to be used by all of the other agents to fulfill their tasks. So here we see the specification, it's got what the URL is, it's got the timing, etc. And that's going to be used by the other agents. If the agents don't have some information that they need, they'll give a question to the same supervisor agent that'll ask me, and the answer will be written to the specification, which will remain the source of truth. So that first agent built a temporary script, which you can see here, which threw sample data into this file. That'll be used as context for the next agents. The first of those next agents is the data model agent that's building the first Moose primitive, which is a data model. So as you can see, this data model here is very well commented with semantic understanding of what the data is. But also we see that we have told it not to store that data because it's just a raw data format. So we'll see the dev server has picked that up, and it hasn't built a ClickHouse table because we told it not to store, but it did build a Red Panda topic and an ingestion API. Now it's asking me, hey, if you want to build a data product, how do you want to transform your data? So I'll say flatten the data to make it easier for OLAP, and then get rid of any columns related to payment networks. I'm not interested in those. That's just an example. You can calculate new fields, whatever you can describe, it's able to do. So the next thing it's going to try and do is build a destination data model that represents the data product that we want. We'll see that show up here. And that'll be different from the raw data model. So we're going to need something to transform one to the other, which is where the streaming functions come into place, which will be the thing that it builds right after that. So now it's attempting to build that flattened data model that we asked for, and we'll see it pop up here. Each of these agents will try up to 3 times, and if it fails, you'll see a big error here, and it'll feed it back to the agent as context. But here it succeeded. So since this is a destination data model, we didn't tell it not to save. So we can see that it built an API endpoint. It also built the table here in ClickHouse, as well as the topic related to it. So now we've got the ingest data model, we've got the flattened data model, and we're building the streaming function to grab that data from the raw data model and conform it to the format expected by the destination data model. So here we've got a function built there, and it is showing you how we are essentially here just mapping files from the source to the destination. Again, this can be much more complex, but this is just by way of example. The final thing it'll do is take this temporary script and try to make a permanent script, which we can use a cron to hit periodically so that we can make sure that we can get enough data to make a time series. So we see that data is hitting our database as we expect. Some interesting things now. At the end of this set of agentic work, we can see that the agents are reporting on what they did. So these agents built these things which are evident in these primitives. So I can go and click into any of these primitives and see what they did and edit them as necessary. You can also see here that if I want to run the cron job, it's asking me to kill the dev server and then restart it. So I'll do that, and then we can see if the agent succeeded. Oh, excuse my typing. So here we are restarting the local dev servers. Here we go. And we can see that data is hitting the database. And then as we told it, every 5 seconds, it is grabbing more data from that API and sending it to the database. But I guess this is one way of proving it, but the best way of proving it is to just show that data in the database. So let's open our ClickHouse database here, and we can see that data, which we collected just seconds ago, hitting that database. If we refresh that view, we'll be able to see more data there as well. Here we go. Okay, that's Aurora. We are very quickly developing it. We're also building other ways of interacting with AI like MCPs. So please continue on this journey with us. Thanks.